and I've shown you a couple of combination pulley systems, and we've also worked out, I've shown you how to work out the mechanical advantage, and explained to you what a fall is, etc., etc. We've done all of that. Now, the last thing is just that there's one other type of pulley which is quite well known and used that you just need to know two things about it. You need to know what it's generally used for, and you need to know what it looks like. And it's, well, three things: what it's used for, what it looks like, and what its name is. Okay? So you have, this pulley system consists out of one fixed pulley and one movable pulley. Okay? One fixed, one movable, with the rope attached up there, pulled around, and down. And that is called a block and tackle. Anybody heard of that before? Yes. Yeah? Okay. Used normally for?
Putting something up.
No.
Fishing.
No. It's not block and tackle as in fishing gear. Yes.
So this is for like lifting heavy weights. So you pull it and then it won't slip, and you can pull it and it won't slip.
It's used for lifting. Yeah, it's got normally with a chain. It's used for lifting car engines out of cars.
Oh yes. So
yeah.
use it for quad.
You will find it in any motor mechanics workshop.
So you don't know.
Find a block and tackle.
Don't you watch that Turbo Night?
No.
Yeah.
On Friday.
I
do know this.
I got a call group.
Why are you busy chatting?
So
was that you?
Chatting to me.
Guy taking the video saw. Both of you. Both of you being warned.
Okay.
Now you've got that recorded too. Okay, block and tackle. That being the block, and that being the tackle. Okay, mechanical advantage of? What's the mechanical advantage then? Two. Yeah, two, because you've got two falls, two ropes which are holding up the weight. Okay, mechanical advantage of two. You just need to need to know the name, what it's generally used for, and what it looks like. If I ask you to draw block and tackle, you need to know that that's what you need to draw. Okay, everybody got that? Okay, so that is pulleys, done and dusted. Now we move on to a completely different set of mechanisms. And the first one we're going to look at has got a very funny name. It is called the Ratchet and Pawl.
Oh, so cool.
Some of you might know what that looks like.
Ratchet and Clank.
Oh, I clocked it in like an hour.
Okay, my drawing of this mechanism is going to look very strange, but it's accurate enough that you can understand what on earth it does. There's a nice drawing of it in your textbook, because I wouldn't technically call this a nice drawing of it.
Neither would I.
Looks like a palm tree.
So you're in the wrong way.
So were you trying to draw palm trees? Because that's a sunflower. It's probably like a gear.
It's a really... Okay, that's a really bad bird. So let me try one more time. Let me try it one more time. Try one more time.
So just draw something. Those ones, like a sword.
It's like a glaive. Now, what do you call it? It's glaive thrower. Oh, so and then like a stick goes into there, and then when you turn it the one way, or a stick.
Oh, that's like.
Okay, that's pretty much what it looks like. Not an accurate drawing of it.
It's a stick,
but
sir.
decent enough. Yes.
Oh, yes, sorry.
Okay. Yes.
Wasn't that something like that in that video you showed the guys last year with the chainsaw, and if your finger touches something goes in like that, then it stops the chainsaw?
No, not quite the same thing. No, I know what you're talking about, but no, not quite the same thing. Okay, that part over there is the ratchet, and this part over here, the pawl.
The clank.
Okay, now this is how it works. Very simple. Very, very simple. If the ratchet is turning in that direction, it turns freely, and the pawl simply runs along the side of the teeth, and will just flop down as it passes over each tooth. So you've got freedom of movement in a clockwise direction. As soon as you try and move it in the opposite direction, that gets stuck and wedged in the teeth and stops it from moving anywhere. And that's how the mechanism works. plain and simply, what would you use it for is if you are lifting anything heavy and you don't want whatever you've lifted up to slip back down. So if you're turning and turning and turning and you have lifted something up on the pulley system, as soon as you stop turning, that pawl will lock it in place. So it's almost a type of locking mechanism. You first, then you, then you. Yes.
So is that the thing that we use like at the back of the stage because for the fly bars?
Yep.
Is that the same
Yep.
thing?
Same type of thing. Yeah.
Would you use that for like as pedal brakes?
I think it probably works on the same sort of system. I've never actually. Somebody asked me that in the last class as well, but I haven't actually ever checked out the mechanism that they use for that. It sounds like the same type of thing because you pedal forwards, and then as soon as you want to brake, you just pedal backwards and it locks. So it's possible that it is the same kind of mechanism, but I haven't actually checked that out. You can go check out and find out for me. See if it is the same one.
So they would have one of those, like, you know, on the trailer of a boat, they have the wrench they would use it for that.
That's one of the well-known places where they use it for winch.
Yeah.
So if you're winching up a boat, you're turning,
yeah.
Turns it up,
and you can pull it off so it's
over a little pulley.
Yeah.
And then when it stops, when you stop turning, it doesn't go backwards because it's got a little pawl which stops it. Yeah. Okay, same thing. It's used a lot in sailing. As he's already said, but when it comes to boats and that. But you guys ever worked in a garage with your dad and he's got a ratchet?
I don't have a dad.
Thanks for that, Mr. Green. Okay, if you know what a ratchet spanner is, okay, which takes sockets. A ratchet spanner works on that exact mechanism. That when you turn it one way, you'll hear it go click, 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 click. That clicking is the pawl moving over the teeth as you turn it in one direction, and then when you go the other way, it locks and you undo the bolt. And then there's a little mechanism which allows you to change the direction on it. Okay, that is a ratchet and pawl. And on that one, the mechanism, all that it does is that there are two pawls. This one, if it's wanted to turn that way, that one's sitting away from the gear. As soon as you switch the switch, this one gets pulled up and that one goes down. And you have the same, and then you're able to move in the opposite direction. That clicking isn't just for fun. That clicking is the pawl, because it's clicking over the edges of the teeth of the ratchet. Okay. Now you know what a ratchet and pawl is and how it works. Okay, that's the ratchet and pawl. Yeah.
That's the rings of pawling, sir.
Thank you. I was waiting for that. Waiting for that. Okay, now, next set. Okay, the next set of mechanisms we're going to look at is a set called a cleat. Okay, yes.
Is that like the one you use in your bicycle pedals?
The shoes? Yeah, it's probably very similar. Probably a type of cleat. Because there are three different types.
Okay.
Okay, there are three different types of cleats. You get a jam cleat, a cam cleat,
and a man cleat.
A clam cleat.
The jam,
Yeah,
sounds like modern
all the ams. Okay, those are the three different types of cleats that you get. Okay, a jam cleat, a cam cleat, and a clam cleat. Okay, now you're going to have to know each of the different types of names, what they look like, and give me an explanation of how they work and what they're used for. So there are four different things you need to know. Name, what it looks like, be able to draw it. Okay, be able to draw it. Tell me how it works, and give me an example of where it would be used. Okay? The jam cleat is most probably the easiest one to give examples of because it's most probably your most common. It simply looks like this. You've got a piece which is bolted into a wall or onto something, and then it's got a K shape. Like that. And pretty much all that it does is you'll immediately should click. If you've got a blind in your house, which doesn't work on little gears like this, and you pull it up, and then you've got to tie the rope somewhere. You wind it around a little thing which is attached to your wall. that is modelled on a jam cleat. Because all that happens is when you wind it around, it winds around that and the rope gets stuck in those grooves. And if it's pulled tight, if you try and pull tight on it, then it just gets wedged more and more into those grooves and it won't come loose. But it's very easy to undo. Okay, that's what a jam cleat is. Used on tons of things. Used a lot in sailing, on boats to secure mast ropes, etc., etc., etc. Used on a flagpole, used on curtains or blinds in houses.
Docking boats as well.
Docking boats as well, yes, there you go, very big ones. Okay, yeah, okay, so there are lots and lots and lots of different simple uses for a jam cleat. Okay, that's the one. Then, the other one, a cam cleat, looks funny. It looks like two teardrops. Let's see if I can draw them properly. Two teardrops which have got teeth on the one side. Okay, this is again not the best drawing. And the rope, the rope goes to the middle of them like that. And pretty much this is how it works. If you want to be able to pull your rope up, you can pull it as long as you can pull it as long as you're pulling it fast and with a swift jerk, because these are spring loaded, which simply means that they're set on springs, so they are normally closed. But if you pull the rope with one swift jerk, then they bounce open and it releases the rope. But unless you do that, the rope is wedged in there by those little teeth. Because if you pull on the rope, the teeth just clamp tighter and tighter onto your rope and stop it from moving. Yes?
So is it like a seatbelt?
Yeah, it would technically be... You see, with the seatbelt, the seatbelt is a little more complicated. The seatbelt is more a ratchet and pull than anything else. Okay? Because with a seatbelt you can pull it when you're pulling slowly, but as soon as you pull hard, then it catches. Okay, that's different. This one's the opposite. This one you can't pull slowly, but when you yank at it, the two teardrops called in this case, okay, those bounce open because they're spring loaded and then allow the rope to come out. So it works the opposite. You wouldn't want that in your seatbelt because you wouldn't be able to put it on, and when you crashed, you'd fling forward. Yes.
So it's kind of like what they use on stages, where you kind of hold the sandbag down.
Yeah.
And you go like that.
Yeah, there we go. Okay, there's a good example. Also used on boats a lot as well for sailing. They use it there as well. Okay. Not so much in rock. Yes, in rock climbing on certain things. Okay, so rock climbing is another example that you can use, but the next one is used the most for rock climbing. Okay, please, there are nice pictures that you can go and look at in your textbook of these. Much better than what I draw.
So the textbook is false.
Eh?
Are they false? Can we study out of it?
Yeah, for these ones you can. Okay, a clam cleat is the one that is used mostly in climbing. Okay, but also again, climbing, sailing, anywhere where you need to be able to wedge your rope into something so it doesn't go anywhere. Okay, I'll try and draw a decent drawing of this.
So is that like in a measuring?
It looks something like that. And the reason why it's called a clam cleat is because apparently these two ridges at the top here look like the two different sides of a clam. Okay? But in general, this is how it works. It's not probably the most accurate way of showing it, but anyway, it's slightly angled in, so that it wedges almost the same way as what a jam cleat does, except it's got one very important difference, and that is these grooves on the sides. So if I had to draw a front view of it, it should look something like this, where it's got a wedge in there, and then it's got little grooves which stick out like that. Now, what that does is that plain and simply you can take it, push it onto a rope, and it will wedge the rope into the groove over there, and then it will make sure, and it will also not move up and down. The little teeth stop it from moving up and down, okay, and wedging it in keeps it on the rope. And they use that for climbing. If you're climbing, if you've got one in your hand, you can push it onto a rope, pull down and climb up. Next one, pushing, climb, pull yourself up, climb up, etc., like that.
So the thing is, you use the one and then the take it and you got it.
Yeah, pretty much. Okay, so you can push it onto a rope and pull down on it, and the rope won't slip through it at all. Okay, that's a clam cleat. As I say, there's a better picture of it in your textbook, and there's also much better, there's nice pictures of them on the internet. Please go and check those out. You guys can all do that quite easily. My picture, not so great. Okay, but again, used in climbing, used in sailing, and anywhere else where you want to tie down a rope. And that is cleats, gentlemen. And that is all we have time for today.